What comes to mind when you think of the term Industrial Revolution? Some of the possibilities might include new power sources, especially steam, heavy machinery, factories, rapid changes in production, new products, social transformation. Any and all of these developments are perfectly valid ways to think about the Industrial Revolution. It would even be fair to say that our entire society, the way we lead our lives today, is a result of the industrialization that began more than 200 years ago. But how did this revolution begin? What happened in society that led people in a particular place and at a certain time to fundamentally change the way they produced things? And what conditions were necessary to spark this radical shift? The Industrial Revolution began in Great Britain in about the middle of the 18th century. It's hard to be precise about the date because it began with a series of fortunate events. And scholars have long asked why it was Great Britain rather than one of the other economies of Europe, as in the Netherlands, where wages were high, trade robust, and consumption growing. Or why the Industrial Revolution didn't begin far from Europe, let's say in China, a country with a standard of living as high or higher than Europe's, and with the technological wherewithal to pull it off. To answer that, we need to consider such factors as the labor force, natural resource endowment, customs and traditions, and the pace of technological change. All of these forces played a role. But for me, the real key to understanding why Great Britain was the leader in the Industrial Revolution lies in examining the unique set of problems that British producers confronted and the solutions they found to overcome such obstacles. Let's begin by looking at the changes that were occurring in the British textile sector during the 18th century, about 40 years or so before the American Revolution. First, we'll see how the introduction of a popular new product generated significant market demand, posing challenges to the old ways of production and uncovering problems that needed to be addressed in the production process. Next, we'll see how these problems were solved by the inventors of the time and how their innovative solutions led to the first steps toward industrialization. We will also discuss the role that laws and policy played in this early stage. For centuries, the English textile sector centered on wool cloth. English wool was in demand all over Europe, and it was considered the best available, and weavers in every country paid top prices for it. English weavers produced for the home market and for the export to European commercial centers on the continent. Now, the trade in wool cloth was regulated by the medieval guilds that controlled production methods, oversaw quality controls, and restricted production to keep prices as high as possible for merchants. Medieval guilds were associations established by craftsmen to control quality, train new practitioners, and provide for the welfare of guild members. The British Crown enacted protectionist laws to support the domestic wool cloth industry, reinforcing guild efforts. It wouldn't be a stretch to say that the entire medieval English economy, from about 1300 to 1500, depended on the ongoing success of the wool cloth industry. However, by about 1550, England, like most other European countries, had begun to develop considerable overseas commercial networks. This overseas trade served as an outlet for English goods, including English wool cloth. But the increase in trade also brought new products to Great Britain. Some of these are obvious to us: spices, sugar, coffee, and tea. Others are not so obvious: ceramics, metals, lacquerware, and new woods like mahogany. British consumers recognized not only the fashion these products imparted, but also their usefulness. Very quickly, British consumers and manufacturers adopted the new products as their own. Think, for example, of English-made Chinaware. The most important of these new imports for our purposes was cotton textiles from Asia. Cotton textiles, imported primarily from India, were immensely popular and soon in high demand in Britain. Imported cottons were much lighter weight than wool, and it was possible to print the material with dyes in a way that was not possible with wool cloth. As the popularity of cotton grew, wool's popularity began to wane. And as you might imagine, the wool cloth merchants and producers alike felt threatened by this shift in tastes. And they started to panic. In a desperate attempt to save their industry, Britain's wool cloth producers sought to restrict the import of woven and printed cotton cloth into the country, starting around the end of the 17th century. Now, the wool cloth producers were a very powerful constituency at this time, and initially they were successful at stopping cotton imports from entering Britain. In fact, as early as 1700, the English Parliament passed a law forbidding the import of printed fabrics from India, Persia, and China, exactly the products that were in demand. Now we know that the Act of 1700 didn't completely succeed, because by 1719, Parliament was again being pressed by wool cloth producers to take action against cotton imports, even though the imported textiles weren't coming close to meeting consumer demand. At the same time, it didn't take long for enterprising men to realize that importing even small amounts of cotton cloth would allow them to begin producing highly desired cotton goods in Britain. This would create the beginnings of a British cotton cloth industry, and it had the potential to generate great wealth. So there was a fundamental shift from wool to cotton taking place in Britain in the early 1700s. And the tight regulations surrounding this shift created a burgeoning domestic cotton industry, spearheaded by some enterprising entrepreneurs. Well, that's certainly intriguing. But you might be asking yourself, what does this have to do with the Industrial Revolution? It sounds an awful lot like the kinds of import-driven changes that were affecting markets all over Europe. But as Britain's new cotton producers got up and running, they began to face some serious challenges. These challenges mainly centered on two factors: production quality and, more importantly, production speed. In order to understand how these challenges arose and how they were overcome, we need to take a minute to understand how cloth had traditionally been produced in England up to this time. And remember, when we talk about traditional cloth production, we mean wool, since the cotton industry was still brand new at this point. Throughout the Middle Ages and early modern period, about 1500 to say 1750, wool cloth was produced by weavers in small workshops all over England. In the classic example, the weaver's entire family would be involved in the production process. The weaver's son carded the wool, his wife and daughter spun it into threads, and the weaver ran the loom. Spinners could rarely keep up with the needs of the weavers, so spinning typically created a bottleneck in the process. When the weaver produced more than he could sell locally, he made arrangements with a merchant to sell his surplus farther from home than local markets supplied. If we think about this in bigger terms, we can see that areas with many weavers could quickly produce more than local region could consume. Merchants were necessary to move surplus production from low population centers to large population centers, and more importantly, to sell it to wholesalers for export. The key was to produce more product and better product for a lower cost. Now, I've been focusing on textiles for a reason. We have an idea in our heads that industrialization came about because of the development of the steam engine and new fuels. Well, this is not entirely wrong. But when we consider the origins of the Industrial Revolution, we need to think more about the organizational techniques of production that were made necessary by a new product rather than the introduction of heavy equipment and new power sources. Let's take a minute to think about what would have gone into producing cloth, any kind of cloth, wool, cotton, linen, etc., around the year 1700. Some of the steps include, first, carding. This is the process where the wool fibers are essentially brushed with paddles that had teasels or pins on them to disentangle the wool fibers to make them parallel to each other. Second, roving. Here the wool fibers that have been carded are drawn out and twisted into longer strands in preparation for the next step. Third, spinning. In this step, the rovings, or long strands of fiber, are further twisted and made into yarn. Fourth, weaving. This is where two sets of yarns are woven together at right angles in order to make a cloth. The cloth is almost always woven on a loom of one sort or another. Fifth, dyeing takes place after the cloth has been made to add color to the natural color of the fibers. Until modern times, dyes were usually made from natural materials and were fixed to the cloth with a liquid solution. Sixth, finishing or fulling was the last step in the process. It added clay minerals to the cloth in order to remove the natural oils from the wool fibers. Well, as you can imagine, if any one broke down, it could pose a major interruption to the overall production. Well, what was the main problem? Which step in the process had the hardest time keeping up, particularly as applied to cotton cloth production? Well, it all boils down to the bottleneck I mentioned a moment ago. Spinners couldn't produce thread fast enough to keep the weavers at peak productivity. But in the cotton cloth sector, the problem was a bit more complicated. British authorities didn't restrict the import of cotton fibers, only the cotton cloth. And yet, British cotton weavers found that domestic spinners couldn't produce high-quality cotton thread the way Asians could. Many British producers concluded that domestic women lacked the small and supple fingers that would allow them to twist finer cotton fibers into acceptable thread. So not only were British spinners unable to produce an adequate quantity to provide the weavers with a steady supply of thread, but the thread itself was of poor quality. The short-term solution to the problem was to mix cotton threads with linen threads when weaving cotton cloth. The cotton thread, which was weaker, formed the woof, the threads that run crosswise. The linen thread, which was stronger, formed the warp, the threads that run lengthwise in the weaving process. This short-term solution solved the quality problem in British cotton cloth production, but it did not solve the bottleneck created by the spinner's relatively low productivity compared to the weaver's high demand. The use of linen in cotton cloth weaving saved this sector, and its modest success early on allowed cotton producers to innovate their production methods in a way that the old, tradition-bound wool cloth industry could not. Wool cloth production was heavily regulated in the various guilds. Consequently, innovation was nearly impossible because craftsmen in each aspect of production fiercely guarded their position in the productive process. In contrast, as I've indicated, cotton cloth production was unfettered by the traditions and customs of the wool cloth producers, and so it was comparatively easy to make changes to the system. In this environment, innovation could thrive, pulling back to capture the bigger picture in textiles. So it was thanks to a new product that the problems that plagued an entire industry were finally addressed. The first invention to increase productivity in cloth making occurred in the weaving process, and initially compounded the spinning bottleneck. In about the year 1733, a man named John Kay, who was a weaver by trade as well as an inventor, came up with an idea to speed up the weaving process. Born in 1704, Kay grew up in the town of Bury in Lancashire, the region of northern England that would become the industrial heartland and technological workshop of Great Britain by the end of the 18th century. Though he worked for a clothier for a time, his real interest was in textile production. When he was still in his 20s, he was making parts for looms. And eventually he invented an improved process for carding and roving. But his claim to fame was an invention that he called the fly shuttle. This device was just a simple improvement on the old cloth looms of his day, but it solved a practical problem for weavers. You see, the crossways threads of a cloth, the woof, were strung across the loom by passing the shuttle that held the threads from one of the weaver's hands to the other. Consequently, the width of a bolt of cloth was limited to less than the length of a weaver's arms. Making wider cloth required 2 weavers, as 2 people were needed to pass the shuttle back and forth. However, John Kay automated the way the shuttle moved from one side of the loom to the other by making it fly. Not only did this allow weavers to make very wide cloths, it also sped up the overall weaving process. Now with the fly shuttle, weavers could produce far more cloth quickly. Of course, many weavers opposed the introduction of Kay's fly shuttle on their looms, claiming that it adversely affected their bottom line. Well, this might sound odd to us, but the weavers felt that they were working harder while not being compensated for the increased production. Well, they were probably right, because as we know from the economic laws of supply and demand, as supply increases, prices tend to go down. Weavers who did employ the fly shuttle also balked at having to pay the royalties that were due to John Kay as a result of his patent. Things eventually got so bad that Kay fled his home in Bury for Manchester. Supposedly, he was hidden in a sack of wool. Eventually, he left England altogether to live in France. Kay probably never expected that a life in exile would be the result of his simple invention. But in spite of his troubles, the fly shuttle soon began to be used generally on English looms, drastically increasing production. Now let's return to our spinning bottleneck. In the days before the introduction of Kay's fly shuttle, it took about 6 spinners to produce enough thread to keep one weaver's loom running. With the fly shuttle, the speed of weaving increased so much that spinners were left even further behind in producing the much-needed threads. Again, what takes place under the laws of supply and demand? Because demand was high and supply low relative to capacity, the price of thread increased considerably when it could even be found. Delays in production were common. Something had to give. A solution to the bottleneck was essential if the fledgling British cotton cloth industry were to survive. Well, the solution to the problem came about as a result of the transfer of patent rights to a metal boring machine. Well, what does metal boring have to do with spinning? Nothing. But the inventor of the metal boring machine was a man named John Wyatt, who'd been a ship's carpenter, the equivalent of a ship's engineer back in the days of sail, before he turned to apply himself to solving the practical problems of manufacturing. Wyatt built his metal boring machine for a man who came into some financial difficulty. And in 1732, this man sold the rights to the machine to another man named Lewis Paul. Now, John Wyatt had also been thinking about developing a spinning machine, and his new business contact, Lewis Paul, was interested in this as well. So much so that apparently Paul promised Wyatt a large sum of money to develop a spinning machine. And the next year, in 1733, about the same time our other inventor, John Kay, introduced his fly shuttle, John Wyatt was testing a new machine that spun thread without, listen to this, the intervention of human fingers. Well, this might sound to us today to be a trivial matter, but for spinners and weavers of the 18th century, it would have been an astounding feat. Consider this for a minute. Go ahead and rub your thumb and forefinger together as if you were twisting a thread. You will notice a slight circular motion, and the pressure of your fingers is not too great. Now, can you think of how you might design a machine to make that exact same motion with just the right pressure? And remember, the machine can't use electricity to run, and the materials have to be available in 18th century England. This machine was a very big deal. John Wyatt later wrote of his excitement as he tested the machine for the first time as being in pleasing but trembling suspense. It took a few years to work out the kinks, but in 1738, Louis Paul took out a patent on the machine. Unfortunately, in spite of its promise to cure the spinning bottleneck, Wyatt and Paul's machine didn't take with spinners. Its parts were delicate, and it required considerable supervision to run. Both men struggled financially and never really made any money on it. Nevertheless, people who saw the device were amazed, so it became somewhat of a curiosity. It was a machine that was ahead of its time, and what it accomplished was proof that it was possible to mechanize the cotton industry. However, another 25 years would elapse before significant strides could be made in mechanical spinning, enough to advance production. The first improvements were the spinning jenny, invented in about 1765 by James Hargreaves, and the water frame, invented in 1768 by Richard Arkwright. The spinning jenny's creator, James Hargreaves, was a weaver and a carpenter, kind of an odd combination. Likely, he worked both jobs because by the middle of the 18th century, the as yet unresolved spinning bottleneck had put many weavers out of work. Hargreaves' spinning jenny was quite simple. It consisted of a rectangular frame on 4 legs with a row of spindles at one end. Lying across the frame were 2 rails that slid back and forth. Cotton fibers passed between the rails and wound around the spindles. The spinster used one hand to move the rails back and forth, and the other to turn a crank, which worked the spindles. It worked perfectly. One woman could now spin multiple spools of thread. But the spinning jenny didn't change the organization of the cloth industry in any fundamental way. Most spinning was still done following the old cottage industry model of small-scale local production. So we've seen that the Industrial Revolution was a long process that began with a fundamental change in the way textiles were produced in Great Britain. We've been looking at some new technologies that were developed to solve production problems. The final steps in the process of industrialization, which we'll turn to now, involved the organization of labor into a factory system and the introduction of non-human power sources in additional processes of production. Hargreaves' spinning jenny had certainly been an important step forward, but it was easily incorporated into the existing structure of the textile sector, where production took place in the homes of spinners and weavers. Richard Arkwright's invention, the water frame, was a different story. It opened the door to a new form of labor organization via factory production. In retrospect, Richard Arkwright was an unlikely inventor. Arkwright was born in Preston in Lancashire in 1732, only a year before John Kay invented the flying shuttle. The family had little money, so Richard could not go to school. He could barely read or write. While still a boy, he was apprenticed as a barber and wig maker. As a young man, he set up his own barber shop and bought and sold hair in much the same way people might buy and sell wool. Yes, he sold hair to wig makers. But wigs were becoming unfashionable by the end of the 18th century, so Arkwright thought he might make a living coming up with new ways to improve on the textile processes. Arkwright wasn't well versed in the technologies of his day, but he certainly made the rounds in the cloth-producing villages of Lancashire, and he probably learned a lot about the cloth-making process in his interactions with villagers. How Arkwright came up with the idea for his machine, which he called the water frame, is so wrapped in myth and legend that we will never know how he hit on the idea. Essentially, it's an improved version of John Wyatt's earlier spinning frame. Arkwright called it the water frame because it was to be powered with a water wheel in much the same way as flour mills were at the same time. Indeed, early spinning factories were called textile mills, a name that stuck for many centuries. Unlike the spinning jenny, however, which was hand-powered, the water frame needed a steady and reliable external power source. As a result, the water frame shifted the location of textile production in a fundamental way. Rather than parceling out the raw materials to workers across the countryside, it was the workers who needed to travel to the mill in order to produce the threads the weavers so desperately needed. This created the factory system, in which the manufacturer centrally located the means of production and hired workers who were required to travel to the factory to do their work. This might seem like a small change, but it was nothing less than a complete restructuring of the physical and social organization of production. A change this fundamental was not without controversy, and as we see so often in the face of innovation, many small manufacturers attempted to block the new methods. But Arkwright's invention took hold, and spinning mills were the standard method of thread production by the end of the 18th century. Spinning by now had advanced to the point that weaving became the new bottleneck in cloth cotton production. Weaving was still done by hand. It wouldn't be until the early 19th century that powered looms began to replace hand looms. In spite of these important technological innovations in textile production, and even the shift to factory-based production, none of this sounds really industrial in the contemporary sense of the word. What had been missing up till now is the introduction of new, more modern power sources. At the beginning of this discussion, I mentioned that one of the things that comes to mind for most people when they think of the Industrial Revolution is the introduction of steam engines. The steam engine was being developed in Great Britain at about the same time as new spinning technologies were emerging, but the key was how to employ the steam engine in manufacturing. And it wouldn't be until the 1780s that the textile sector successfully adopted the steam engine. Arkwright saw very clearly that replacing the old water wheels with steam engines will allow for greater productive output because the mills would no longer have to be located on fast-moving rivers. Now steam engines began to replace water power everywhere and in most industries. What I'm saying is that the development and application of the steam engine was the decisive stage in the foundation of the Industrial Revolution, because this was the invention that facilitated large-scale industrial production. I'll conclude by making a few broader observations about the steady move toward industrialization in British cotton manufacture. I mentioned earlier that on the eve of the Industrial Revolution, in the early 18th century, woolen goods were far and away Britain's most important industry. Cotton, by comparison, was then an extremely small part of the country's textile sector. It's quite possible that the small size of the cotton industry allowed it to be so innovative in much the same way as small startups today can grow into huge companies. British cotton producers were not constrained by the traditional methods and customs that governed the woolen industry. However, the changes in the British textile industry that I've outlined were only the first steps in the march toward industrialization. British producers had other problems to solve due to the changing circumstances. And that's a story for another day.